Now, part 2, even just looking at it makes your head hurt a little bit, right? They do give you a clue. They say, considering a geometric series, right, can you evaluate this limit? Now, by the way, don't forget, this is a part 1 and a part 2, right? So you are expecting somehow, eventually, this result will appear somewhere in here, right? So even though clearly it's not obvious, you always have to have that in the back of your mind. What are you looking for, okay? Right, so let's give this a go. First, we'll start with the GP. The GP is just the numerator, right? So I'm going to say the numerator is, now it's a GP, and I know the 3 features of it that comprehensively define a GP, right? That's the first term, the ratio, and then how many terms, right? So what's the first term? It's e to the power of 1 on n. It's a bit awkward, but fine. Okay, what's the ratio? What am I multiplying by as I go from one term to the next? It's also e to the 1 on n, right? Can you see that? Because index laws, right? Index laws. To multiply this to this, right? Or if you like, divide this by this, or divide this by this, this is what you're going to get out. Are you happy with that? Watch out, okay? How many terms are there? N terms, that's nice. I prefer to say n terms rather than n equals n, because I think that's confusing. Okay, great. So therefore, if I've got a, r, and n, I can say the numerator is equal to, and then I'm going to pull out my sum of a GP formula. Okay, so let's give this a go. It's the first term, it's a. Then I've got r to the n minus 1, right? R to the n. R to the n? What's r to the n? Index laws, index laws. It's just going to be e, right? That 1 over n times n, so I'm just going to get e. Okay, there's my r to the n. Minus 1 all over, what's on the denominator? It'll be r minus 1, since this is r to the n minus 1, right? So I've got this. Sure, all right, fine. So there you go, there's your numerator. So therefore what I'm actually evaluating, the question is, the limit as n approaches infinity of, there's my numerator, all over e to the 1 on n minus 1, okay? And then I divide everything through by n. So if I divide this by n, the n just kind of jumps onto the denominator. Is that okay? It just kind of sticks on here. Are you happy with that so far? Okay. So what we've done is we've considered the GP, got rid of the GP now, and then you look at this and think, ugh, right? Now, I told you this is a multi-part question, okay? So, is there anything here, anything, that bears any resemblance to part 1? And you have to stare pretty hard, I admit. That's what makes this a last question type question. Okay. Now, to make it a little bit easier for you, in case it's not jumping out at you, right? This is a limit, right? It's a limit with regard to n, okay? So the n's need to stay in here, but not everything has to do with n, right? There's some stuff I can pull out because it's not that important. What can I pull out? I can pull out e minus 1, right? It's just a constant. So e minus 1 out the front, okay? Which leaves me with, whoops, sorry. E to the 1 on n, and e to the 1 minus 1. Okay, so this is a bit tinier. Now you have to stare at this long and hard and compare it to this. Now, clearly you can see it is different, okay? Now here's a helpful exercise to go through, right? It's different. What are the ways in which it is different? Okay, so you can see that there's something upside down, right? This has a e to the whatever minus 1, right? Well, this also has an e to the whatever minus 1, but it's on the denominator, right? So it's like, okay, so that's a bit weird, right? So it's flipped. Question mark. Tell me another difference. I can see some others. Pay careful attention. There's some obvious things about this, right? Yeah. Good, good. So this limit is approaching 0, right? Whereas this one is approaching infinity. Huh. Now there's one other obvious difference, which is that I mean that's h's and this is n's, right? You have a look, this is not just n's, this is 1 over n, right? There's 1 over n's everywhere, okay? That seems to be the main thing. So instead of h, right, I have 1 over n. That's what I'm getting. Now look at this. Look at all of this. We've just looked and we've seen what's different between what I've arrived at and what I'm supposed to use eventually, right? Now can you see these are actually just 3 different ways of saying the same thing. 3 different ways of saying the same thing, right? The whole limit is flipped. Well, by coincidence, the variable that we're taking the limit of is also flipped, right? And then you compare where your limit's actually approaching, well, one's 0 and one's infinity, which is kind of also flipped, right? Okay, so here's the question. I need to get from here to here and somehow use this thing. Okay, how can I do it? I will do one more thing, which hopefully will make it clear, and then I wonder if you can help me out. Okay, here's what I'm going to do. Here's my e to the 1 out the front. I've got this limit here. Now remember I said to you, it's all in 1 over n's instead of h's, right? With one exception. Which term? It's that n there, right? So how do I turn this n into a 1 over n? If I want this to be a 1 over n instead of an n, right? Then it shouldn't be on the denominator. It should be actually up here on the numerator, right? So let me write it like that, okay? I've got the e to the 1 on n over here. I'm going to put him out the front. I hope you'll see why in a second. Then I've got my 1 over n here. Okay, so I've done 2 things. Number 1, I've changed this n, which was on the denominator, to 1 over n on the numerator. And the other thing, I've separated this guy out. Okay, can you see why I did that, by the way? Do you see why I separated it? I'm trying to make it look as much like this as possible. Okay? Okay, I'm almost there. I need to do all the pieces now to be able to use that result. Okay? So you notice the big problem is that it's flipped. The big problem is that it's flipped, right? Actually, this is not so much of a problem. Because think about this, right? If you've got some kind of fraction, some ratio, right? And it's approaching 1, right? Well, the special thing about ratios that approach 1, for instance, what's the other famous ratio that you know that approaches 1? X approaches, yes, sine x on x, right? But when we looked at this result, we also noticed that who cares whether sine x or x is on the top or the bottom? It doesn't matter. Because you're approaching 1, you can put x up here and sine down here. No big deal. 1 over 1 is still 1. Okay? So we look at this and we think, oh, it's weird that it's flipped. But that's okay. Because it's approaching 1, and only because it's approaching 1, you can just flip it. No problems. It's still the same limit because and only because it approaches 1. Can't stress that enough. You can't just go flipping limits because you want to, right? You can only flip them when they're approaching 1. Okay? Alright, now, you ready? Instead of 1 over n, I wanted h's, right? So let's do this, okay? Let's say, I'll keep it in red. Let's let h equal 1 over n, okay? Now this has a whole series of implications. For instance, when n approaches infinity, I should write my n's and h's carefully because they look very similar. When n approaches infinity, what's h approaching? 1 over, it's approaching 0, right? Okay, so I'm going to substitute this. This is my substitution of what the limit will be. Okay, so I can put all of this now into here. Okay, let's do it. What am I going to get? I'll have e to the minus 1. This limit is no longer a limit in n. It's no longer going to infinity. It's a limit in h, and it's going to 0. Okay. Instead of e to the 1 on n, I'm going to have e to the h. Okay. And then up here, I'll have, that's just h over e to the 1 over, sorry, e to the h minus 1. Okay, right. So this guy, this is good. This is good. Right, because I can use this, right? But there's this guy in the way. What do I do with this? What can I do? Well, if you remember back to limits, I don't know, I can't remember if I taught you this. You might have learned this before me. The limit of a product is the product of the limits, right? So you can actually break this apart into 2 limits. I can say it's the limit of this times the limit of this. That is obviously funnier than I thought. Why is that funny? Anyway, okay. The limit of a product is the product of two separate limits. Okay? This is the limit I was after. I finally got him into the question. It took a lot of twisting and turning, but we got there. Okay? So this guy is going to be 1. This guy is just e minus 1. What's this guy? This is just e to the h, right? He's nothing fancy. Here's e to the h, right? And as I approach h equals 0, I'm coming into this value, right? That guy there, 1. Okay? So you've got e to the e minus 1 times 1 times 1. It's e minus 1. Okay? So this is a hard question. It's hard because they kind of lead you in, but it's very non-obvious how the lead-in actually is useful to you. Okay? So I hope that makes sense.